Okay, we're going to take a look at section 2.3, where we're going to be figuring out linear equations and slope. We're going to figure out how to graph our linear equations if we're given an equation for that linear equation. If we're given an equation for the line, we're going to figure out how to graph that equation and create the line on the 2D coordinate plane. We're also going to be working it backwards, and we're going to say, okay, if we're given information about the line, how do we write the equation that represents that line? So first we're going to take a look at graphing those linear equations, and there's a couple of ways of doing it. Now we've looked at the point plotting method. Actually, there's 3 ways to do it. The point plotting method we've already looked at, and it's a tried and true method. It's just kind of long and tedious. So let's find a couple of shortcuts that we can take. Now the first shortcut that we can take is using our X and Y intercepts. We've already talked about X and Y intercepts, and remember, mathematicians are not creative at all. We call it like we see it. So an X intercept is going to be where the line intercepts, like a football interception, or intersects the axis. And again, if mathematicians are not creative, then that means the X intercept is going to cross the X axis. So here's a picture of a line that's cutting this X axis at this point right here. So this is the X intercept. Now what I'm saying is, let's say you're given an equation for this line and you need to find that X intercept. Well, any of these X-intercepts, they always sit on this axis, and what do you know about every single one of the points on that axis? Notice that every one of them, there's no up or down movement at all, and your up or down movement is signified by this Y-coordinate on your point. So if there's no up or down movement, then what do you know about this Y-coordinate? Right, your Y-coordinate has got to be 0. Now my X-coordinate can be anything. It could be positive, negative, it could be fraction, it could be decimal, who knows? But what I do know is that my Y-coordinate is 0. So in other words, if you're given the equation for that line and you need to get this X-intercept, what you do is you set your Y-coordinate equal to 0, and when you do, the only variable that you have left will be your X variable. So you'll solve for your X, and that will give you the X-coordinate and your 0 for the coordinates for that X-intercept. Now, on the flip side, if you need to get your Y-intercept, similar idea, that the Y-intercept is going to be where the line crosses the Y-axis, or intersects it, intercepts the Y-axis. So here's a picture of that. Here's your line, and you can see right there's your Y-axis, and here's where it cuts through it. So the same idea is that every one of these points on this Y-axis has something in common. What's common is that there's no left or right movement, and left or right movement indicates which variable. Yeah, that will be your X variable. So you know that every one of these points on this line has an X coordinate of 0, and the Y coordinate can be anything. It could be positive, it could be negative, fraction, decimal, I don't know. But what I do know is the X coordinate is 0. So like I was saying before, if I'm given the equation of the line and I need to find my Y-intercept, then what I do is I say, well, I'm going to make my X 0. When I do that, I'm only left with a Y-coordinate, so I'll solve for Y, and that will give me the coordinates for that Y-intercept. So this is how you get your X-intercept and your Y-intercept. And how many points does it take to make a line? Yeah, 2. You'll have your 2 points. You'll have your X-intercept, you'll have your Y-intercept. You can connect the 2 with your line. So let me give you an example of how this works. Taking an equation and solving it for the X-intercept, solving it for the Y-intercept, and then putting those 2 points on the graph so we can see what the line looks like. So in this example, what we are told to do is graph the line represented by the equation 5x plus 4y minus 20 equals 0, and we want to graph it using our X-intercepts and Y-intercepts and the Y-intercept. So in order to do this, let's take a look first at that X-intercept. Now remember, the X-intercept, and the things that I had written up there, most of that I don't have memorized. Honestly, the only thing that I have memorized is the definition of an X-intercept. An X-intercept is where, here's my 2D coordinate plane, it's where it crosses this axis right here. Every single point on this axis has no up or down movement at all. That means my Y coordinate is going to be 0. So if I need to get an X-intercept, that means I make my Y 0, because a lot of times people get it twisted and they'll make their X 0 to find the X-intercept. But no, it's going to be the Y coordinate. So that means I'm going to right here pop a 0 in there. When I do, I'll have 5x plus 4 times 0 minus 20 equal to 0. And now remember, 4 times 0 is 0, so that term is gone, and this is what I'm left with. I only have an x coordinate now. That's easy to solve. I'm just going to add 20 to both sides, and then I'm going to go through and I'm going to divide by 5. That will give me x equal to 4. Now this is a point in the 2D coordinate plane, so I need to express it in coordinate form. Very, very important that you express it in coordinate form, because it is a point in the 2D coordinate plane. In this point, the x coordinate is 0, the y coordinate is 0 because I made the y coordinate 0. But that's the first point on that line. Now I need to get my y-intercept. And in order to get the y-intercept, again, I don't have all that stuff memorized that I showed you before on the last screen. The only thing that I have memorized is that here's my 2D coordinate plane, a y-intercept crosses this axis right here. On this axis, there is no left or right movement at all. No left or right movement indicates that the x coordinate will be 0 for that point. So what I'm going to do here is I'm going to make my x coordinate 0, and that means that in this equation I'm going to throw a 0 right here where that x is. So now it'll be 5 times 0 plus 4y minus 20 equal to 0. And this term is 0, it is now gone, and I'm left with a 4y minus 20 equals 0. And like I said in the other one, I'm only left with one variable that happens to be a y. That's easy enough to solve. I'm going to add 20 to both sides, and then I'm going to go through and divide by that 4. 20 divided by 4 is a 5. And yet again, this is going to be a point that's in the 2D coordinate plane, so I need to express it in coordinate form. And I made the x coordinate 0 when I did the y coordinate came out to be a 5. That's the point on the 2D coordinate plane. And remember, it takes 2 points to make a line. I've got the 2 points. So in order to graph this, I'm going to put those 2 points on here. And my point 0.5 sits right up here. My point 40 sits right there. There's the 2 points. I'm going to connect them. Ta-da! There's the line that is represented by that equation. So this is how you graph your lines using your x and y intercepts. Now, another feature for graphing lines is whenever you have horizontal and vertical lines. And these tend to confuse people really bad. They get them twisted pretty severely. But I have found a way to keep it straight, and it has everything to do with how you read the equation. So I've learned to read my equations in a different way. So let's take a look first at an equation that would look like this. Y equals B. That's a B, not a 6. Now, typically what we do is we read it as y equals b, but I'm going to read it a different way. I'm going to read it as y has to be whatever that letter is. Because when I read it that way, then I completely understand how to graph this line. So let's take a look at an example here. And in this example, we're going to graph the line that's represented by that equation. Now, we all read that equation. I read it as well as y equals 6. And that is what it is, y equals 6. However, we need to read it in a different way because the equal sign means exactly this, has to be. The y has to be a 6. So if I look at my 2D coordinate plane, all right, here's my 2D coordinate plane. On this 2D coordinate plane, where is the y 6? Yeah, nobody has any problems with finding that the y is 6 right here. But now notice within this equation that there are no x coordinates. In other words, I kind of don't really care what x is. I just need to guarantee that that y is going to be a 6 on every single point that's on that line. X can be anything I want it to be. Positive, negative, fraction, decimal, just make sure that the y is a 6 on every one of the points. So where else in this 2D coordinate plane are points that have a y coordinate of 6? Okay, there's one up here, there's one over here, there's one back here, and one back here, and one back here. Now if I would connect all these points, what type of line have I made? Absolutely, that is a horizontal line. So every single equation that's in this format will always generate a horizontal line. Now let's talk about these x-intercepts and y-intercepts that are on this horizontal line. X-intercept and y-intercept. On this particular one, what is the x-intercept? bearing in mind, keeping in mind that the x-intercept is where it crosses the x-axis. So where does this line cross this x-axis? You're right, it doesn't. So how would we express the x-intercept? We would express it as none. Don't express your x-intercept as 0, because what that is saying is that it's crossing right here at 0, and that's not what's happening. It's not crossing at all, so you just simply express that there is no x-intercept. Typically, that will be the case whenever you have a horizontal line. The only time that you won't, or that it will not be none, is if your horizontal line is sitting right here on the x-axis. Now, if that's the case, then every single point on the x-axis will be your x-intercept. But that's a very rare case. Typically, your horizontal lines sit up here somewhere or down here somewhere. So typically, you won't have an x-intercept. Now, let's talk about this y-intercept. Keeping in mind that the y-intercept is where it crosses the y-axis. Here is your y-axis, and that line is crossing right up here at the point 6. But let's put it in coordinate forms because that is a point on the 2D coordinate plane. Points are always expressed in coordinate form. Notice here, at this particular point, there's no left or right movement at all, so the x-coordinate is 0, the y-coordinate is 6. What do you notice about this point here and this equation here? Yeah, the 6's are the same, and that will happen every single time. Whatever this number is, that will be the y-coordinate for your y-intercept. So you will always have an x-coordinate of 0 because it crosses this y-axis right here. Every one of these points has an x-coordinate of 0. And whatever that number is, that will be the y-coordinate for your y-intercept. So that's how you graph equations that look like this. And I will tell you that all of this stuff right through here, I don't have any of this memorized. The only thing that I have memorized is this phrase right here. I know how to read my equation. So whenever I take a look at these equations, I always read it as y has to be 6. When I read it that way, I can generate my line, and then all this information here I can pull from the picture. So you don't have to have any of this stuff here memorized. Now, let's take a look at graphing a vertical line. So what happens with that is your equation looks slightly different, and this time your equation looks like this. And once again, we all read that as x equals a, and I read it as x equals a, but I'm learning to read it as in a different way, and instead now I'm going to read it as x has to be whatever that a is. Because when I read it that way, it's very easy to graph that line. So let's take a look at an example, and this time I'm going to graph the line that's represented by the equation x equals -3. But again, I'm not going to read it as x equals -3, I'm going to read it as x has to be -3. Because that's what the equal sign means. This has to be whatever that number is. Now when I read it as x has to be a -3, I look at my 2D coordinate plane and I say, okay, where is the x of -3? Right here. And then I look at this and I say, well, there's no y in there, so I kind of really don't care what y is. Just make sure that the x is -3 on all of the points that are on that particular line. So the y can be positive, negative, fraction, decimal, doesn't matter, just make sure that the x is a -3. So where else on this 2D coordinate plane are x coordinates that are -3? That's here, and here, and here, and here, and down here, and down here. Okay, so if I connect all these, now what type of line is that one? Yeah, that one is going to be a vertical line, and that will happen every single time that you have an equation that looks like this. Now, let's talk about, again, these x-intercepts and y-intercepts. Keeping in mind that the x-intercept is where it crosses the x-axis. So on this particular example, where is this line crossing the x-axis? Absolutely right here. And the coordinates for that point are going to be -3, 0. And just like we said in the last one, do you notice anything special about this? Yeah, whatever number is here is going to be the x-coordinate of your x-intercept. And that will happen every single time that you've got that vertical line. So my x-intercept will always be whatever that number is, 0. Because if it's going to cross this x-axis, then that means that I've got no up or down movement at all. This y-coordinate will always be 0. And then whatever number you see there will always be the x-coordinate for that. Now let's talk y-intercept. Y-intercept is where it crosses this y-axis, and notice this one's not. So just like we said in the last one, there's not going to be a y-intercept. And like we said in the last one, that's typically going to be the case whenever you've got these vertical lines, unless the vertical line is the y-axis. Now when that happens, then every single point on the y-axis is going to be your y-intercept. But that doesn't happen very often. It's very rare. Typically they're over here or over here, and in which case it's not crossing that y-axis, you're not going to have one. And like I said in the last one, I don't have any of this stuff here memorized. The only thing that I have memorized is how to read it. And now that I read my equations in different ways, I can get those lines graphed beautifully every single time. And by graphing it correctly, I can pull all this information out. Okay, so this is how you can graph your lines using your X and Y intercepts. And like I said, we've already looked at point plotting method. And this is how you graph your horizontal and verticals. So now let's take a look at this concept of slope, because the need to use slope allows us another shortcut for graphing our lines. So first, let's look at what slope means. A lot of people are familiar with slope. You've used slope for a long time, but a lot of people don't understand what slope truly is. Slope is going to be your steepness of a line, or in other words, the tilt of the line. And so if it's a tilt, then what it's going to be is a rate of change. In other words, what's happening when I'm talking about slope is I'm saying, here is my line that's within this 2D coordinate plane. And if I'm going from this point right here to this point right here, I'm asking myself, as I make that movement from here to here, how much am I moving up in comparison to moving across? And so by doing that, what I'm looking at is I'm creating a definition of slope. Now, when we talk about slope, we always use a lowercase letter m to represent slope. And let's say that I want to figure out the slope for going through these 2 points, and we'll call this one x1, y1, because this is the x coordinate and the y coordinate for the first point. And going through, let's call this one x2, y2, because this is the x and the y for the second point. It doesn't mean square it. It means the x and the y coordinates for the second point. So I've got a line that's going through, and it's a line, I need to put arrows on here. It's going through these 2 points, and I want to figure out that slope. So again, what I'm looking at is how far up am I going in comparison to how far across to get from one point to the next. Well, when I'm looking at that, what I'm looking at is this rate of change. Now, in science and math, this little triangle delta, it's a Greek letter delta, and it means I want to do the change in height versus the change across, or the change in distance. Or maybe we'll call it change in length. In other words, I want the change in these y coordinates right here in comparison to the change in these x coordinates. Because y coordinates are the vertical and x coordinates are the horizontal. So actually that would be better, rather than height and length, let's do vertical change and horizontal change. So vertical is y and horizontal is x. Now if I'm going to do this vertical change here, how would I get the difference from here down to here? Well, notice that this point right here has a y coordinate of y2. And so to get this vertical change, that would be, let's subtract those y's. In other words, let's pick some easy numbers. Let's call this a y of 2 and this a y of 5. The change there would be 3, because 5 minus 2 would give me 3. So to get this vertical change, what I'm going to do is I'm going to subtract those y coordinates. And now I'm going to do that horizontal change. Well, notice to go from here to here, this point here has this x coordinate of x1. So if I want to do this horizontal change, it's the same idea that when you're doing a change, you're doing subtraction, a difference. So what I'm going to do here is I'm going to do the difference of these two. And so what I'll do is I'll say, let's do an x2 minus an x1. This is what we call your formula for slope. Now be very careful with this formula, because a lot of people get it twisted and they'll put their x's on the numerator and they'll put their y's down on the denominator. but it's gonna be y's on the numerator, x's on the denominator. One way to remember that is what we call it's not a formula, but a definition of slope, and that's rise over run. And think of it this way, whenever you rise, like if I rise like this, that was a vertical change. So my rise goes with the y's, and whenever I run, I don't run hills. You people who run hills, you're crazy. I run on a horizontal. So the run is going to be your horizontal change. So rise over run indicates difference in the y's over difference in the x's. The other thing that you have to be very careful about is that whatever order you designate when you subtract those y's, you have to go in the same order on the x's. It doesn't matter the order you could subtract the y's. I could have done y2 minus y1. I could have done y1 minus y2. It makes no difference at all. But once you designate that order, you have to go in the same order on the x's, because if I'm doing the difference from this point to this point, when I do y2 minus y1, I have to do this point minus this point on those x's. I can't reverse the direction. So this is where the formula for slope comes from. And if you understand where it comes from, it makes it much easier to use. So now we're going to use it, and I'm going to go through a couple of examples of using this formula for slope. And in these examples, we are going to calculate the slopes of the lines passing through the given points. And in my first example, we're going to utilize the points 6, 4, and -6, -4. So what I'm going to do, since I'm given 2 points, is I'm going to use my formula for slope, which says let's subtract those y's on the numerator and let's subtract those x's on the denominator. Now, like I said, it doesn't matter the order you subtract the y's, just make sure you go in the same order for the x's. So if I go -4 minus 4, I'm going to go -6 minus 6. -4 minus 4 is a -8, -6 minus 6 is a -12. Always simplify your fractions if you can. -8 over 12 definitely reduces to be positive, and 4 goes into both. 4 goes into 8 twice, 4 goes into 12 3 times, so my slope is going to be 2/3. Had I chosen to subtract it in a different order, had I chosen 4 minus a -4, I would have gone 6 minus a -6, but subtracting a negative is really adding a positive. So I'll get 4 plus 4 is 8, 6 plus 6 is 12. That still simplifies to 2/3. So see, it really doesn't matter the order you subtract the y's, just make sure you go in the same order on those x's. So now let's try a couple more. These last two that I'm going to do are two that typically people get really twisted on. A 3, 7, and a -4, 7. So I want to find the slope that goes with these. So what I'm going to do here is I'm going to use my formula for slope. And if you have a formula that you need to memorize, the easiest way to memorize it is just simply to write it down every single time that you use it. You will memorize without even trying. So I'm going to subtract my y's on the numerator. Now notice that 7 minus 7 is the same thing, so it really doesn't matter the order that I do that. And I'll subtract my x's on the denominator. 7 minus 7 is 0, plus a positive. Even if I would have done -4 minus 3, I would have got a -7 in the denominator, but it kind of doesn't matter because I have 0 in the numerator. And when 0 is in the numerator, your answer is 0. Now, let's try another one. Let's go with 6, 1 and 6, 8. Yet again, here what I'm going to do is I'm going to use my formula for slope, and I'm going to subtract my y's on the numerator and my x's on the denominator. So I'll choose 8 minus 1 on my numerator, and the denominators are the same. So I'm going to get a 0 on my denominator, and 8 minus 1 is 7. If I would have done 1 minus 8, I would have got a -7, but it kind of doesn't matter because I got a 0 in the denominator. When 0 is in the denominator, my answer is undefined. Now, if this confuses you and you can't keep straight which one is which, here's how you remember it. Whenever you have a fraction, your numerator tells you how many objects that you've got. Your denominator tells you how many groups you're dividing it out to. So say, for instance, in this one, this says I don't have any markers in my hands at all to pass out. But there are 7 of you out there to receive these markers. So I don't have any markers to pass out. How many markers does each of you get? Yeah, each of you gets 0 markers. As opposed to this one that says I have 7 markers in my hands to pass out, but there's nobody out there to receive those markers. So I'm trying to pass them out. I'm doing my best to give them out, but I can't make the action happen because nobody's out there. So if I can't make the action happen, it's an undefined action. So that's why 0 in the denominator is going to be undefined. Now, let me give you a little trick for remembering slope. This is not something that's necessarily scientific, it's not a formula, and it doesn't really truly help you with knowing the numbers for slope, but it is kind of helpful in terms of, it helps a lot with this idea of 0 slope and undefined slope. Because, do you like skiing? See, I don't like skiing at all. Could not get out of snow plow, something about the little sticks on my feet and going down that mountain really fast, it doesn't work for me. But anyways, we are gonna go skiing. Now, what happens here is, here's my mountain and we are going to work our way up that mountain. But the problem is that the ski lift is broken. So we have to work our way up the mountain without a ski lift. And so that's going to be a pretty exhausting experience, and we are going to puff our way up that mountain. So what puff indicates is that we have a positive slope. And so what that tells me is any line that tilts in this direction, I may not know the numerical value of that line, but I definitely know it has a positive slope. Kind of like the one that we just did. If I have a 6, 4, and a -6, -4, that was the first example that I just erased. Well, what happens there is 6, 4 sits over here, 2, 4, 2, 4, 6, sits right here, -6, and -4 sits right down here. Remember, we had calculated a slope of positive 2/3. So that has a positive slope, and it does tilt in the direction like we said. So the skier reaches the top of the hill and is going to go downhill. Now, for those who like skiing, downhill is super duper nice. I am not an artist, that's okay. So we're going downhill, and that's nice. What that indicates is negative slope. So any line that tilts in this direction, I may not know the numerical value of it, but what I definitely know is it has a negative slope. Now here's where this is super helpful. Any line that is horizontal, here's my skier. We've been skiing all day. We are completely exhausted. So we're going to take a nap. And what that means is on these horizontal lines, we're going to have 0 slope. Now let me point out that that coincides with what we have in this example right here. Notice that if I was to graph those points, 1, 2, 3, 4, 5, 6, 7, there's 3, 7, and here's -4, 7. Sure enough, when I graph those points on here, it creates a horizontal line. We had calculated a 0 slope for those. The reason we have 0 slope is because whenever we do the change in the vertical, notice here on this line, as I go from this point to this point, there is no vertical change at all. We're just simply going across. So if there's no vertical change, that means you're going to have a 0 in that numerator every single time. So therefore, 0 in the numerator indicates 0 slope. That indicates horizontal line. Horizontal lines will always have 0 slope. Now here's where it gets really interesting. So my skier has hit a cliff. And my skier, this is terribly, terribly morbid. I'm so sorry. But my skier is falling off the cliff and shouting, "Oh no," and is going to be undefined in the end. I know it's awful, terribly awful, but you will never forget that a vertical line has an undefined slope. So tying that in, let's take a look then at your vertical line here. If I graph this, 1, 2, 3, 4, 5, 6, 1 sits here, and 6, 8 sits right here, making a vertical line. And we had calculated an undefined slope on that one. And again, the reason that it's undefined is because right here, this horizontal change, well, if you look at these points here, horizontal change moving left or right, I'm not moving left or right when I'm going from one point to the next. I'm only going up and down. So since there's no horizontal change, that puts a 0 in the denominator, and every time you have a 0 in the denominator, it's an undefined slope. So yes, your horizontal lines will always have an undefined slope. So like I said, this is just nothing really necessarily mathematical, no formulas there, but it helps you to remember definitely these two where people get them twisted. But it also, you know that when you have a line going in this direction, it has a positive slope. When you have a line going in that direction, it has a negative slope. So now that we know how to use slope, what we're going to do is take a look at that use of slope in terms of being able to graph lines, because we've got our point plotting method, we've got our X and Y intercepts, and now there is a third method for graphing your lines, and that third method is using that slope. So let's take a look at the slope-intercept form of the equation of a line. Now your slope-intercept form of the equation of a line is y equals mx plus b. Within that form, we have a slope, and I said that slope is always going to be represented by that letter n. And remember, slope is that counting tool of rise over run. Didn't utilize it a whole lot in those last examples. We'll definitely use it a lot here. Also within that, you've got a y-intercept, and that y-intercept is going to be the b. However, that is a point that's within the 2D coordinate plane, so I'm going to put it in coordinate form. A y-intercept here is my 2D coordinate plane. It's going to cross somewhere along this axis, meaning no left or right movement at all. That indicates that the x-coordinate is going to be 0. So now that I've got those two pieces of information, I can use those two pieces of information to graph the line. The catch is you always graph your line by plotting the y-intercept first, then using rise over run. Then use that counting tool. Rise over run is a beautiful counting tool, but you have to have a place to count from. So you put your y-intercept on there first and then use this. A lot of people will start here at the origin, they'll count their slope out and then put their y-intercept on there and connect them. But you only use this counting tool after you have a place to count from. So you absolutely must start with your y-intercept first. So now let's take a look at some examples here of how to use this. So let's see here, C, D. So in these examples, what we're going to do is we are going to find the slope and y-intercept. And then we're going to graph the line using both. Okay. So our first example says 4x plus 3y equals 9. Well, in order to pull out the slope, remember that form looked like this, y equals mx plus b. What is significant about this is that this y is by itself. Once the y is by itself, then I can pull out the slope, then I can pull out the y-intercept. Notice in this one, the y is not by itself. Well, we know how to manipulate equations. We know how to rearrange them. So what I'm going to do first is get rid of this 4x, because in order to reverse order of operations and remove everything away from the y, if I knew what the y was, I would multiply it by 3 and then I would add this 4x. So the last thing that I say is the first thing that I fix, and I'm going to remove it first. And now what I'm going to do is go through and divide by 3. Keeping in mind I'm dividing the entire side by 3. So now the y is by itself. Now I'm in slope-intercept form, and I can pull out the slope, I can pull out the y-intercept. When the y is by itself, the slope is always going to be the number that's right in front of the x. So my slope is -4/3, and my y-intercept is going to be 3. But remember, this is a point in the 2D coordinate plane, so you always need to express it in coordinate form. The y coordinate on the x coordinate on a y-intercept is 0. The y coordinate in this case is going to be a +3. So now I have the information that I need to be able to graph it. Remember, my counting tool is fabulous, but I have to have a place to count from. So I'll start with my 0, 3 right here, and then I'll use this slope. The negative here can sit out front, it can sit on the top, it can sit on the bottom, just not in both places, top and bottom, because if you put it in both places, what type of fraction do you have? Yes, you've got a positive fraction. This is clearly negative. So wherever you want it to be, it doesn't matter. I'm gonna toss it on the top because that's where most people put it. So my rise is -4. The fact that it's negative means I'm not rising up, I'm rising down. So I'm gonna come down 1, 2, 3, 4. My run is positive, and on my x-axis, everything positive is to the right. So I'll come down 4, right 3. Here's the second point on that line. It only takes 2 points, and I've got both. So now I can connect them, and there's my line. Notice that we said we had a negative slope, and this is that nice negative like we saw there on the picture. So there's one example of how to take an equation and manipulate it to get the slope and the y-intercept. Let's take a look at another example now. Because this one tends to cause some confusion for people. I've got a 3x minus 2y equal to 0. And what I'm going to do here is, yet again, I'm going to get the y by itself so that I can work with it, because as it stands right now, I can't find the slope or the y-intercept. So I'm going to remove that 3x, leaving me with -2y equals -3x, plus 0 if you want, but you don't have to show that part. And now I'm going to go through and divide by -2, giving me y equals a +3/2 x. So now the y is by itself, like we said before. I can pull out that slope, I can pull out that y-intercept. So when the y is by itself, the slope is the number right in front of the x, and the y-intercept is going to be whatever is being added to it. And remember, we said that we were actually adding a 0 over here. So my y-intercept is going to be 0, 0. This 0 because it's a y-intercept and there's no left or right movement at all. This 0 because that's what the y-intercept was. That's enough information to be able to graph the line. This one confuses people because without this piece, they don't quite know what to put for their y-intercept. But just remember, if you're not adding anything, that means your y-intercept is a 0. So now, great counting tool, but I have to have a place to count from, so I'll start here at 0, 0, rise 3, and run 2. Positive, and positive means go up because all your positives are up, and then go positive on the right because all your positives are on the right side of your x-axis. And there's my line, pretending that it's straight because I can't draw a straight line. But notice this was positive, and yes, puff, puff, positive, just like we saw, so it does make sense. So this is the third way to graph lines. You've got your point plotting method, you've got your x and y intercepts, and now you've got your slope and y-intercept. So now what we're going to look at is how to take the information and write the equation in line. In other words, work backwards. Given the slope, given the y-intercept, being able to create it. Or given a couple of points, being able to write the equation line. So like I said, working backwards. Now the first thing that we're going to look at in order to be able to write the equation in line is this idea of what's called the point-slope form in the equation in line. What I'm going to do is I'm going to show you where the point-slope form comes from. Now here is your formula for slope. Subtract the y's on the numerator, subtract the x's on the denominator. What I'm going to do is I'm simply going to rearrange this formula. Now we've talked before about if you have a fraction, in order to wipe out the fraction, all you have to do is multiply by the denominator, because when you multiply fractions, you're going to cancel on those diagonals and then you're going to shoot straight across. Well, in order to cancel on this diagonal right here, I need to multiply this side by this entire denominator of x2 minus x1. And we said that whatever you do on one side of the equal sign, you have to do on the other side of the equal sign. So I'm going to multiply this side by the very same thing, x2 minus x1. These will cancel out completely, and I'm left with x2 minus x1 times m equal to y2 minus y1. Beautifully done, because now the fraction's gone. We also talked about multiplication being commutative and associative, so you can reorder, that's your commutative property, you can reorder the way that you multiply. Here I've got parentheses times m. So could I rearrange it and do it m times parentheses? Sure, completely legal because of my commutative property. So what I'm going to do now is I'm just going to rearrange and put m times x2 minus x1, leaving this side alone. The other thing that we've talked about is the idea that this is a pan balance. The equal sign is that fulcrum that's in the middle. If I have a pan balance and I spin the pan around like this, does it change the balancing act? No. It might teeter a little bit like this, but it'll level out. So if this is a pan balance here, can I take this side of the pan and put it over here, and this side and put it over there? Completely legal because it's all equaled out and balanced out. So I'm going to take this and put it on this side, y2 minus y1. I'm going to take this and put it on this side, m times x2 minus x1. And it's legal because it's a pan balance. Now, the last thing that I'm going to do to show you where the point slope form comes from is, remember that these subscripts simply indicated that this x and this y go together. These are the x and the y's for the second point. This x and this y go together. These are the x and the y for the first point. So if it's just a matching thing, could I take this one off and take this one off, and these two still be matched up? Absolutely. This, my friends, is the point slope form of the equation of a line. It is simply your formula for slope rearranged. That's all it is. But once you've got that point slope form, you can identify your slope, because slope will always be m, and you can identify a point that's on the line. Now, the reason I took the subscripts off of these two is to remind me these are going to stay as variables. These two are actually going to be numbers. These numbers will be the points, or the x and the y coordinates for the point that's on the line. So that point will have an x coordinate of x1 and a y coordinate of x1. And if you've got a point and a slope, that's all it takes, because you put your point on there, you use your slope to count, and then graph it. But more importantly, if I'm working backwards and I want to write the equation of the line, this is used to find the equation of the line when given the point and the slope. Because if I'm given a point and a slope, I'm going to put my point right here, I'm going to put my slope right there, and I will write the equation of the line. Or when given 2 points, which is kind of confusing, because you may be saying, no, wait a minute, I need a slope. But if you're given 2 points, can you find the slope? Absolutely, because you plug it into the formula for slope, and there you go. You've got a slope and then 2 points to choose from. Now, it doesn't matter which point you choose from, and I'm going to prove that to you. So we're going to go through some examples here to show you how this point slope form works. All you really need is this point slope form that you see right here. I was just simply showing you where it comes from. So, in these examples, what we're going to do is, in each, we're going to write the equation of the line given the specified conditions. And then we're going to transform it transform the equation into slope-intercept form. So in our first example, we know that the slope is going to be 1/2, and we know that the line is passing through the point -4,3. So we are given a point, we are given a slope. That means we can utilize our point slope form in order to find the equation of that line. So I'm going to, and again, if I've got a formula that I need to memorize, what I'm going to do is I'm going to write it down every single time I use it, and then I'm going to plug my numbers in By writing it down that many times, you will memorize it without trying, and you'll have to have that memorized. Now remember, I took the subscripts off of this one and this one to remind me that they stay as variables. These three are going to be numbers. So my slope will go right here where this m is. The x will go right here for this x coordinate, the one that has a subscript on it tells me that's going to be a number, and the 3 will go right here for that y. Now with point slope, I like to do what I call cleanup. Cleanup is, I know that subtracting a negative is really adding a positive. This is much cleaner, it looks nicer than the other format. So this is my point slope form of the equation of the line. But my directions said, let's take this and let's transform it into slope-intercept. Now remember, slope-intercept had that y by itself, and it looked like this. So what I have to do is I have to get this y by itself. Notice also there's no parentheses in here. So I need to remove the parentheses on this one. Now you can add your 3 first and then distribute your half through, or you can distribute the half and then add the 3. I typically distribute through first and then add to keep me from distributing too far. Because oftentimes people just don't think and they distribute too far all the way back to the 3. So I'm going to distribute my half through and get a half x plus 2. That gets rid of the parentheses, it's looking better. I just need to add the 3 to the other side. So I'm going to get y equals 1/2 x plus 5. There, that's slope-intercept form because the y is by itself and I have no parentheses in there. So that's what happens whenever you're given a point and a slope and you need to write the equation on a line. Let's take a look at an equation now where we're given 2 points and how to write the equation on the line if you're given 2 points. So let's say that I know that it is passing through the point 3, -2 and the point 5, 1. Now remember, I can use my point slope form, y minus y1 equals m times x minus x1, but I need a slope. So what I have to do is I have to utilize my formula for slope first and then go from there. So my formula for slope is going to say let's subtract the y's on the numerator and subtract the x's on the denominator. And we said it doesn't matter the order you subtract the y's, any order that you want. I went this one minus this one, so I'm going to have to do the same order on the x's. -2 minus 1 is a -3, 3 minus 5 is a -2, negative over negative is positive, so I have a slope of 3/2 here. Now I'm going to utilize that information in order to write the equation of the line. And remember, it doesn't matter which point that you choose to use, and I'm going to prove that to you by doing both points. So let's choose the first one here. So this is going to remain a variable, and this is going to remain a variable. My slope of 3/2 is going to go right here. If I choose this point, then my y1 is going to be -2, and my x1 is going to be 3. Cleaning that up, this is going to be y plus 2 equals 3/2 times x minus 3. And that's going to be my point slope form. Now, what if I would choose the other one instead? This one right here. So here's my point slope form. And this is a variable, and this is a variable. My slope is still 3/2, so I'm going to put my 3/2 in here. Now my y is going to be 1, and my x is going to be 5. There's no cleanup to be done in that one, so this is my point slope form. But see, if half of the people chose this point, you'd get this, and if half the people chose this point, you'd get this, and everybody would be arguing because they don't look the same. But this is the beauty of transforming it into this slope-intercept form, because you're going to see that they all are the same thing. They're going to rearrange into this same equation. So in order to rearrange this into that slope-intercept form, remember the y needs to be by itself and no parentheses. So I'm going to distribute through first. And I'm going to get a 3/2 x minus, put this 3 over 1, cancel on the diagonals, but nothing will cancel. I'm going to shoot straight across and get a 9/2. Now I'm going to subtract the 2. That gets the y by itself. I get 3/2 x, and I'm just going to take that -9 over 2 and subtract the 2 over 1. I'm going to get that common denominator of 2, and this becomes 4 over 2, and that gives me a -13 over 2. That is going to be slope-intercept form. Now, if I take this one and rearrange it into slope-intercept form, similar idea, let's distribute through. I get a 3 halves x minus, put the 5 over a 1, so I get a negative 15 over 2. I'm going to add the 1 to both sides. I'm going to get a 3 halves x. Now, I need to, again, get that common denominator of 2 over 2, and negative 15 over 2 plus 2 over 2 is a negative 13 over 2. And that's going to be slope-intercept. And you can see that what's circled in blue in both cases is the same thing. So what I have circled in black, what I have circled in green, they do represent the same equation. Or not the same equation, but they do represent the same line. What's circled in black, what's circled in green, and what's circled in blue all represent the very same line, just 3 different ways to write the equation for that line. And writing those 3 different ways is important. It's kind of like my name is Lori James. But if I wrote my name James, Lori, I would be the same person. It's just 2 different ways to write my name. And these are 3 different ways to write the equations for those lines. So let's look at just a couple more examples, and then that will finish this out. So let's say that I've got a situation here where it is passing through the point 4, negative 3, and the point 3, negative 3. So like we said before, what I have to do is I have to get the slope. So I'm going to subtract my y's on the numerator and my x's on the denominator. When I subtract the y's, notice they are the same. So it kind of doesn't matter how I subtract the x's because my numerator is going to be a 0. And like we said before, when the numerator is 0, my slope is 0. So now I've got a slope of 2 points to choose from, and I just proved to you it doesn't matter which point you choose. So let's choose this one. Doesn't matter. So I'll do y minus y1 equals m times x minus x1. And yet again, I'm going to write that thing down every single time I use it so that I can memorize it without even trying. My slope of 0 is going to go right here. I chose this point, so my y-coordinate is going to be a negative 3, and my x-coordinate is going to be a 4. Now here, this is y plus 3, and on this side, this is 0 times x minus 4. So there it is in point-slope form. But now if I transform it into slope-intercept form, remember that means get the y by itself, but 0 times anything at all is what? Yeah, it's just a 0. So this is y plus 3 equals 0, and to get the y by itself, I'm just going to subtract a 3, giving me y equals negative 3. And that's my equation in slope-intercept. Now, if you notice, if we were to graph this, here's 4, negative 3, and here is 3, negative 3, giving me a horizontal line. Notice on this horizontal line, every one of the y-coordinates is a negative 3. And so the equation for that, if you look back in your notes at the beginning, this is the equation that represents that horizontal line, y equals negative 3. So this makes total sense. Also, well, I'll come back to this in a minute. So now, let's take a look at one more example. And in this last example, come at 1, 2, 3, this is number 4. Okay, it's passing through the points. This time it's going to be 5, 2, and 5, negative 3. So yet again, I need to get the slope first. So I'm going to subtract my y's on the numerator, x's on the denominator. Y's, I'll do a 2 minus a negative 3. Could have done the other way, doesn't matter. Notice the x's are the same, so my denominator is 0. So it really doesn't matter what's up on that numerator. 0 in the denominator means undefined. So now I've got the slope, and we said I've got 2 points to choose from. I've already proven to you it doesn't matter the point you choose. Let's choose that one. So here is my point-slope form, the equation of the line. This is going to be a variable. That's going to be a variable. I'm going to put my 2 right here. I'm going to put my 5 right here. And the problem is, what am I going to put right there? I can't put a word in there. That makes no sense at all. So now what? Well, if you notice, take a look at the points that are up here. What do you notice about those points? Yes, both of them have the same x-coordinate of 5. How do I write x has to be 5? X has to be 5. So there is your point slope form along with your slope intercept form all in the same shot. Now, refer back to the other example that we had prior to this one where I started to say something and then stopped myself. Notice that those points were 4, -3 and 3, 3, excuse me. For those of you who have sharp eyes, you're going to notice right away that within these, they've got the same y-coordinate. And how do we write y has to be a -3? Y has to be a -3, which is exactly the answer that we got there in the end. So if you've got sharp eyes, you don't have to go through all this. If you can notice, oh, ta-da, I've got the same x, well, it's x equals 5. And if you can notice, ta-da, I've got the same y, then it's just y has to be a -3. So those are some shortcuts that you can take. Okay. So this is how you write your equation of the line. If you're given a point and a slope, or if you're given 2 points, you can plug them in there. And then this is how you graph your equation of the lines. Thanks.